So let's get started in setting up a test. So where do we begin? There's going to be some factors that affect the test, how well we can do our test. These are factors such as the test pressure that'll be used in the part. These are factors like the material the part is made out of. Is it a soft material? Is it a hard material? Will it want to move and give way? The volume of the part. Is it a very small volume? Is it a medium volume? And is it a very large volume? Those factors will determine what we can do as far as the test timers and setups. For example, why would the test pressure be something that we need to be concerned with? Can we just test with any pressure? Well, think of it in the case like a doctor. The Hippocratic Oath says, first, do no harm. So one of the factors we need to think about is, when I pressurize my device, will that be causing harm? Could I stretch the part? Could I cause a crack or a fissure to occur? We don't want to test at such a high pressure that the part will never see that pressure in actual use. And keep in mind, when we talk about keeping fluids in or keeping fluids from getting in, that air and water are two different sizes. The molecules are with such great distance between them that air can actually escape, but a liquid like water or alcohol could not escape from the same size hole. To illustrate what pressure is going to do, let's say, for example, I have this glass jar. This represents our part we're going to be testing. Not that we're trying to test the glass for something, but so this is our part. And if I take some marbles, I have some little blue marbles, they represent the air molecules, and this represents the part we'll be testing. So when I begin to pressurize my part, every time one of those air molecules come in contact with another air molecule or the part, it makes the noise. We hear that noise. Well, that noise is the air molecules exchanging their energies. And that's the basic definition of heat. So we're heating up both the part and the molecules inside the part. Well, the ideal gas law tells us as the air inside increases in temperature, the pressure also increases. Well, the second I stop adding any new air to the part, the thermodynamic effect that just took place starts to calm down. And so we start to see the pressure drop. Well, with a system with a sensitivity such as the Z series, that drop in pressure will show up and you might think, wow, I have a leak. I'm seeing the pressure decay on the screen. When actually it's a phase change of compressing air into a set space. The higher the test pressure, the more I'll be compressing and setting those molecules and changing their energy to the point where they're now creating more and more heat. So we'll need to be able to nullify that factor somehow, or when we see that decay, it might mask the decay that we actually have air leaving the part.